Hi, I'm Teacher Hernan and welcome to Math for You. In this video, the topic is about divisibility rules. Before we start, please subscribe and click the bell button if you want to be updated with my new videos. Sometimes, you only need to know if a number can be divided by evenly, or when you divide, there is no remainder. What if you don't have a calculator or a writing paraphernalia? How will you do that? Well, the divisibility rules can help you a lot. Let's start with divisible. By the way, when you say divisible, when a number is divisible by another number, when you divide them, they will give you a remainder of 0. Let's start with divisible by 2, 5, and 10. Look at the example, numbers that are divisible by 2. What do you observe? Yes, the numbers are all even numbers, right? Since the ones digits are even. If a number is an even number, you can tell right away that that number is divisible by 2. Meaning, when you divide by 2, there is no remainder. That's easy, right? What about divisible by 5? How will you know if a number is divisible by 5? Look at the given examples here. If you notice, the ones digit is 5 here, and here, then the ones digit is 0. If a number ends in 0 or 5, or the ones digit is 0 or 5, then you can tell right away that the number is divisible by 5. That is, when you divide the number by 5, there is no remainder. What about for divisible by 10? Do you notice something? Yes, the numbers here ends in 0, or the ones digits are zeros. So if a number ends in 0, you can divide it by 10. Definitely, there is no remainder. Now let's proceed with divisible by 3, 6, and 9. Let's start with divisible by 3. How will you know if a number is divisible by 3? The rule says, add the digits of that number. Then if the sum is divisible by 3, then the number is divisible by 3. Look at the given example, 258. The digits here are 2, 5, and 8. So just add the digits 2 plus 5 plus 8, which is 15. So that is the sum of the digits, 15. Then, divide this 15 by 3. If there is no remainder, meaning that number is divisible by 3. Again, 15, the sum of the digits divided by 3 will give us 5. There is no remainder. The remainder is 0, right? So you can tell that 258 is divisible by 3. Now let's go to divisible by 6. The rule says, if a number is divisible by 2, and that is even number, and divisible by 3, and that is the sum of the digits is divisible by 3, then the number is divisible by 6. So let's have the given example. Let's use 258 again. Is this an even number? Yes. Meaning, this is divisible by 2. Is this divisible by 3? Yes. 258, a while ago we said it's divisible by 3, since the sum of the digits is divisible by 3. Again, this number is even, divisible by 2, and divisible by 3. That means this number is also divisible by 6. Now let's have divisible by 9. Divisible by 9 has the same rule with 3. Again, it says just add the digits. The number is 747. Let's add 7, 4, 7. That will give us 18. So the sum is 18. So what will you do with 18? Divided by 9. It will give us 2. There is no remainder. Meaning, this number, 747, is divisible by 9. Now let's move on to divisible by 4, 8, and 12. Are you ready? Look at the example for divisible by 4. The last two digits are 2 and 4, or 24. Can you divide 24 by 4? Is there a remainder? None, right? If the last two digits can be divided by 4, leaving 0 remainder, then you can say that that number is divisible by 4. So here, 1,224 is divisible by 4. Or, if the last two digits are zeros, you can say that that number is divisible by 4. So there are two rules for 4. The last two digits can be divided by 4, or the last two digits are zeros. What about divisible by 8? If 4, you look at the last two, for divisible by 8, as you can see, you look at the last three digits. If the last three digits can be divided by 8, then that number is divisible by 8. Is 728 can be divided by 8? What do you think? Yes. If you divide this by 8, that will give you 81, or 91 rather. There's the remainder, right? So you can say that 3,728 is divisible by 8. Or, if the last three digits are zeros, that number is also divisible by 8. What about for divisible by 12? Here you have to consider two things. The number must be divisible by 3 and divisible by 4. So we have to go back to rule 3, divisible by 3 and 4. Again, what's the rule for divisible by 3? Yes, add the digits, right? Let's add the digits. 8 plus 5 plus 3 plus 2. What is the sum? 18. Can 18 be divided by 3? Yes, that will give you 6 with 0 remainder. Meaning, this number is divisible by 3. Then go to divisible by 4. Again, the rule says, look at the last two digits. The last two digits, 3 and 2, or 32. Can you divide 32 by 4? Yes, the answer is 8, leaving 0 remainder. Again, the number is divisible by 3 and divisible by 4, meaning that number is also divisible by 12. So you can say that 8,532 can be divided by 12, or it's divisible by 12. Lastly, let's have divisible by 7 and by 11. So how do we know if a number is divisible by 7? Well, you see, if the difference, to know if a number is divisible by 7, if the difference of twice the ones digit and the remaining digit is 0, or multiples of 7. How is that? Let's have example here. The number is 126. Well, it says the difference between twice the ones digit and the remaining digit. So what's the ones digit here? It's 6, right? So what will you do with 6? It says twice, so you multiply it by 2. That will give you 12. So you subtract this to get the difference with the remaining digits, which is 12. So subtract this here. 12 minus 12, 0. If the answer is 0, or multiples of 7, then you can say that number is divisible by 7. Again, as a review, what are the multiples of 7? You have 7, 14, 21, and so on. Very good. You should remember our lesson in the previous or in the other video. Now, reminder, if the difference here still has a lot of digits, just continue the same procedure. Multiply by 2 the last digit, then subtract to the remaining digit until you get smaller difference. Again, the answer must be 0 or multiples of 7. So, for you to know if the number is divisible by 7. Let's have the last one, divisible by 11. Now, how to know if this number is divisible by 11? Well, you simply add or get the sum of the alternate digits, then subtract. If the answer is 0 or multiples of 11, then that number is divisible by 11. How is that? Look at this example. 2,904. What are the alternate digits here? Let's start with 2 and 0. That's the first alternate digits. What will you do with 2 and 0? You simply add them. 2 plus 0, that's 2. The next alternate digits are 9 and 4. So it's 9 plus 4, that's 13. And after that, what will you do? You get the difference of these two. Get the difference of the two numbers, or the two sums here. So, to get the difference, you need to subtract. So, let's subtract 13 minus 2. The difference is 11. Again, if the answer here is 0 or multiples of 11, then we can say that this number or that number is divisible by 11. Now let's see if you can recall the divisibility rules from 2 to 12. Are you ready? Let's start with 2. Yes, the number must be even number. What about 3? The sum of the digits must be divisible by 3. Correct. What about 4? Yes, you look at the last two digits. If the last two digits can be divided by 4, or if the last two digits are zeros, you're right. What about by 5? Yes, if the number ends in 0 or 5. What about 6? Yes, you're right. If the number is divisible both by 2 and 3. So you have to go back to divisible by 2 and 3. What about 7? We just discussed a while ago. Yes. Multiply the ones digit by 2, then subtract to the remaining digits. Again, if the answer is 0 or multiples of 7, the number is divisible by 7. You're right. What about 8? Yes, you look at the last 3 digits. The last 3 digits can be divided by 8. And the last digit or the last 3 digits are zeros. What about for 9? Yes, it's similar to 3. You simply add the digits. If the sum is divisible by 9, then the number is divisible by 9. What about by 10? Yes, if the number ends in 0. 11. Yes, you add the alternate digits, then subtract the sum. If the answer is 0 or divisible by 11, then you can say that the number is divisible by 11. And lastly, 12. Yes, if the number is divisible both by 3 and 4. Now, let's complete this table by putting check or X inside the boxes. If this number is divisible by the top numbers here, we will put a check. If it is not, we'll put an X inside the box. Let's start with divisible by 2. Is this number divisible by 2? What do you think? Check or X? Yes, you're right. It's check. Why do you say so? Because it's even number. You're correct. What about 3? What's the rule for 3? You simply add the digits. Let's add the digits to 7, 8, 0. If you add them, that's 17, right? Can you divide 17 by 3? No, there's a remainder of 2. So, meaning to say this number is not divisible by 3. So, we will put an X here. What about 4? What's the rule for 4? We look at the last two digits. What's the last two digits here? 80. Can you divide 80 by 4? Yes. There's no remainder, right? So we'll put a check. What about for 5? What's the rule for 5 again? If the number ends in 0, it ends in 0, so it's divisible by 5. What about for 6? What's the rule for 6? It must be both divisible by 2 and 3, but it's not divisible by 3, so it's not divisible also by 6. What about for 7? What's the rule for 7? Multiply the ones digit by 2, then subtract to the remaining digit. Let's do that here. So the last digit is 0. So times 2 is 0. So if you subtract 0 here, you should get 7278. So just continue the same process. So the last digit times 2, that will give us 16. Then subtract it to the remaining digits here. That will give us 11, right? Now, how will you know if it is divisible by 7 if the difference is 11? We said if the answer here, if the difference is 0 or multiples of 7, that number is divisible by 7. But the difference is 11, not 0, not multiples of 7. So it's not divisible by 7. So we will put x there. What about 8? It's the last 3 digits. What's the last 3 digits here? 780. Can we divide 780 by 8? Is there a remainder? Let's try. 780 divided by 8. That's 9 times 8, 72. That's 60. That's 7, 56. If you can see, there is a remainder of 4. It simply means that this number is not divisible by 8. So we'll put x there. What about 9? What's the rule of 9 again? Add the digits. Again, we said the sum of the digits is 17. And 17, not divisible by 9. So another x here. What about for 10? Yes. It ends in 0, meaning this number is divisible by 10. So we'll put a check there. What about for 11? What's the rule? Get the alternate digits and subtract. The answer must be 0 or multiples of 11. Let's do that here. The alternate digits are 2 and 8. That's 10. Then 7 and 0. That's 7. Then minus 10 minus 7. That's 3. So it's not 0. It's not multiples of 11. What does it mean? Yes, this number is not divisible by 11. And lastly, 12. What's the rule for 12 again? It must be both divisible by 3 and 4. It's not divisible by 3, only by 4. So it's not divisible by 12. So we'll put an x there. That's all for now. Thank you for listening.